Morning all. Okay. So in today's class, from today's class, we are going to discuss about the machine learning concept. Okay. So today we will see the short introduction about the machine learning. So what do we mean by machine learning? Can anyone say in the chat? So what is the difference between like we are saying artificial intelligence, machine learning, deep learning, so many things we are saying, right? So what it actually means? Machine learning means what basically?
To understand the emissions.
To understand the mission, is it right?
Yes, sir.
No, we don't understand the mission, right? We make the mission to learn or understand. Teaching methods to think like a human. Yes. So machine learning, in general terms, if you ask for a definition, what is machine learning is, what we can say is machine learning is a study of a computer algorithm that provides the systems the ability to automatically learn and improve from experience. Okay, so automatically in the sense, one time if you have feeded or created the model means each time when it makes the mistake, it will try to learn from its experience and it will correct it. Okay, in very simple one line, if you want to say means learn from data and solve the problem. Okay, like that we can say. So it is machine learning is generally a subfield of artificial intelligence. Okay, if you are drawing one diagram means artificial will be the bigger circle. So inside the artificial intelligence, machine learning will be taking the major role. So inside the machine learning, we will be having the deep learning, and if we go deeper in deep learning also, we will be seeing the neural network. Okay, and data will be a part of all three layers. Okay, otherwise let me share. So as I told, uh, so if I say the bigger circle is artificial intelligence means, so inside the artificial intelligence only, we will be having our machine learning part. Okay, machine learns by using the algorithms. So which are the things we will be seeing in the machine learning part. So inside the machine learning, what is there if you see means it will be having the deep learning part. Okay, DL we will say. So using different methods, our machines will try to understand. For example, if I want human will see, right, using their eyes. So how machine can see? So they can see through cameras, right? Okay. Then what else we can say? Human can five senses humans are having, right? Touch, speech. For speech, what to speak, what human will do? Like we can say voice, right? For machine, what we will use? Like some sound device we will use, right? A voice assistant and all now we are having, right? Sound voice devices will be using. For sense, so we are having various organs like touch. Using the touch, we can feel something, right? How machine will feel using the sensors. Okay. Human can taste food and other things, but a machine cannot taste. What else? So most of the things machine will be doing some similar like human using the machinery parts. Okay. So and we call it as text. So for reading purpose, what we will use machine, we will be using the NLP, natural language processing. For reading the text or speech purpose also, we will be using the natural language processing. Machine takes power, we takes food. Okay, then inside the deep learning part, if we are coming means it will be connected with neural network. Okay, so in this entire thing, data science will be a part of. Okay, for everything we need data only, right? So data science will be the part of all the layers. Okay, so what we can say, machine learning algorithms allows the system to make decision autonomously without any external support. Here external support means without any human intervention, it has to take the decision. So such decisions are made by finding the valuable underlying pattern. Okay, if I ask a human, okay, I'm showing two things. For example, I'm showing the mobile phone and one apple or other fruit item I'm showing, and I'm asking the human how you are saying it is a fruit or a smartphone. Everything means up to few extent only you can able to describe the particular product. What you will describe, okay, for example I'm showing an apple, okay, and then banana, both are fruits we know. So how you are differentiating this is apple and this is banana? Based on the color, shape, right? But few more parameters also will be there, like we can say taste also. If I close your eyes also, based on the shape you can say, based on the taste you can say. But when I want to train the machine based on the parameter, means we need to feed lot of information, and each time we cannot say the machine this is apple, and we cannot set the condition. If so many condition we cannot set. Why? Because if I say to a machine apple means it will be in red color, okay, and then it will be like oval shape, okay, round or oval you can say, okay, and banana means it will be in yellow color. And for this what shape we can say, uh, what we can call this shape, okay, some shape is there, like that I'm feeding means it has been trained in such a way. What if I bring a red banana? We are having red banana also, right? So what if I bring a red banana and show it to a machine? What will happen? At the same time we are having green apples also is there, right? We cannot set multiple condition. What if the size of the apple is very small, or I have chopped the apple, okay, at the time how it will predict? So many criteria we cannot set, right? But we can give the machine some pattern like 100 or 1000 apple images I can pass, okay, good apple, bad apple, like that I can feed it to the machine. And it will try to find the pattern out of those images. Okay, images when I say means it will be converted into pixels. Okay, each pixel will have some numerical value. So based on that it will understand, okay, and we will label the image also. Okay, later we will see what is labeling the other things. So such a way, if I am feeding 1000 apple images and 1000 banana images means I will be newly checking with some new image I will show to my machine. Okay, say what fruit it is. Okay, instead of showing apple and banana same size, I'm showing the orange. Okay, so it should say either it is unknown, it will say. If it is an not properly trained model means it will say apple also, right? Because structure, I mean shape matches. Okay, maybe color also in its assumption, it may think orange also as an red color. Okay, or if I'm sending some black and white images, then what will happen? So those type of scenarios has to be taken care by the human at the initial stage. While the training part human will be uh, doing all these things. Okay, wherever it is making mistake we will try to resolve it, train it, retraining, tuning. Okay, all this we have to do. Later on it will become a model. So then we can deploy it in your real-time application. Okay, so based on this type of learning approach, the type of data that we are putting it as input. So what is important here is what type of input you are putting into our data, I mean a model, and what type of output you are expecting from our model. So based on this, we are having three category. Okay, so these are the types, primary types we can say. So first is supervised learning. Okay, hope my screen is clearly visible. Right. So first thing is supervised learning. So it is applied when the data is in the form of input variables and the output will be in the form of target values. So as I told, we are feeding with input data apple and banana means only two things we can able to identify. Each image we have to label this is apple, this is apple. To make it easier, what example we used to give is assume that one child is there, newborn child is there. So how you will train the child? Okay, this is an apple, this is a stone. You should go here, you should not touch this. Everything will be repeatedly saying to our child, right? After some point of time, the child will be able to understand. Okay, this is apple means in this shape it will be there. This color will be there. This taste will be there. Like that, it will try to imagine it, right? So similar way for our AI also, we are to train by giving the labeled image. Later on, when I show one new image means it will say it is a apple. Okay, it is a banana, it is a unknown. Like that, it will reply to us. Okay, so understood. So in supervised learning, it will be categorized into two types. Okay, um, these approaches, this main two categories are there, which is nothing but the classification and regression. Okay, if the output variable is one of some known number of categories, for example, I want to differentiate whether it is a cat or dog. In the example we have seen is apple or banana. Okay, or positive or negative, like that. If you are classifying means, then we will call it as a classification problem. So based on this type of classification, we are having various algorithms. Okay, so these are some of the algorithms which will be using for classification model. So we are having k nearest neighbor algorithm is there, support vector mission algorithm is there, decision tree algorithm is there, random forest is there, navy bios, the neural network, even more are there. Some of them can be used in both classification as well as regression type of problem. For example, we can use decision tree for regression as well as classification. Lot more is there. Basic, if you see, means we will be having a linear regression classification will be there. So when you go for the regression type of model, okay, output will be in the form of real or a continuous value. Okay, for this, what example we can give is we can say price. Okay, price of a gold or a petrol, a Bitcoin. So those and all will be in continuous values, right? We cannot say some fixed value or fixed category. We cannot say house price prediction. So many examples are there. So for there and all, we will be using this regression type. Okay, in this we are having three main algorithms, which is linear regression, logistic regression, and then polynomial regression. Okay, so in upcoming classes we will be seeing about each algorithm per day, and then one project related to that particular algorithm. Okay, so I want you to now itself start practicing for the machine learning concept also. That is what classification means: fixed output. Fixed output in the sense we can precisely say this is the output, like as I told, right, a cat or a dog, animal means animal category, which is that we can say. Regression means mostly it will be like numerical value or the continuous value, like as I told, we can say a price example. Based on this, what are all the example you are able to get? Can anyone say? Hmm? For regression classification, what example you can able to say? Okay, I'm saying earthquake prediction. Okay, what will be the earthquake today or particular day? What type it will be? Whether it is a classification type or regression type? Earthquake prediction or rain prediction is there, right? That and all will fall under classification or regression. Huh? How you will classify? I'm not asking whether rain will come or not. What will be today? How much rain today it will be? What will be temperature today? So in Windows also, if you have seen in the down segment, is showing, right, 33 degrees Celsius, 35 degrees Celsius, like that. It will be varying in value, right? So that and all will come under regression part. Classification means fixed. This will be my output. Digits, if I'm saying means 0 to 9 only, it is going to be my output. Fixed number of values. Regression for forecasting, those things we will be using. Okay. So, so this is first thing. Then, so this comes under the supervised learning. Most of the time we will be dealing with the data in the supervised learning type only. Okay, we have to give the label data to our model. Okay, label data in the sense we will be passing both input as well as the output. Both we will pass to our model. Okay, based on that it will try to find a pattern. Okay, and out of if 10,000 data we are passing, okay, into our model, means for testing purpose what we will do is like 80% of the data we will be giving to the training part. Okay, 20% we will keep it for the testing part. Okay, which means we will know the actual value. What will be our actual value we will know, but we will only pass the features. Okay, we will say like independent variable, dependent variable, like that we will be saying. Okay, so independent variable means each feature will be called as an independent variable. Okay, so based on that independent variable only we will be getting one dependent variable called y. Okay, which is going to be our output. So we will only pass the input and we will check whether our model is predicting the output or not. Okay, as I told here, I am passing the apple, right? In the same case, I will be passing orange or any other fruit item and I will check whether it is predicting it as an apple or not. For example, in the place of banana, similar like banana, what fruit I can keep to test my, what we can say, to test my model. Similar like banana, any fruit is there? Okay, good. Cucumber or anything I can place and I will check whether it is predicting it as a banana or not. If it is predicting as banana means our model is having some error. Okay, it should not predict like banana, right? So those things we will be checking. So this comes under supervised learning part. Then the next type is unsupervised learning. Okay, so in unsupervised learning, we will only pass the input data. We will simply pass the image of apple and then banana. Okay, our machine itself has to find the pattern. Okay, here machine doesn't know this is a apple or this is a banana. What it will do is it will try to segregate based on the pattern. Okay, each step by step it will try to analyze the pattern and it will automatically separate them into different categories, but it doesn't know the name of that particular images, grouped images. Okay, here how we can easily define is unsupervised learning is applied when the data is available only in the form of input and there will be no any corresponding output variable. Okay, such algorithm model that underlying pattern in the data in order to learn more about the characteristics. Okay, so if I am passing pen, marker, and then what we can say spoon, okay, spork, like that I am passing. Okay, so what it will do is pen and marker will have similar features, right? Even when we go for the spoon and fork means, again, that is also having some similar features, like that it will group them into single cluster. Here we call it as a cluster, and the algorithm we will be using in the unsupervised learning is known as clustering. Okay, clustering means nothing but group. Okay, based on the same category characteristics, it will group the data into different cluster. Okay, so here if you see means I'm not passing in an order. Okay, here if you see means I am passing apple and banana in like order. First apple images alone I will pass, then banana images alone I will pass. Okay, it will be labeled. Okay, see here I have mentioned like labeled also. But here I will not label my image. I will pass randomly apple, banana, whatever fruit is there I will pass. So it will try to it has to try to understand the pattern, and then it has to segregate into two parts. Okay, apple images one group, and then banana images another group. Okay, sorry. So in unsupervised learning, so main category is clustering, and another one we are having is known as association. So in the association category, we will be having one algorithm called arpirioid algorithm. API or OD something O will be there. So that algorithm we will be using. And the famous data set for that particular algorithm is supermarket data set will be there. One supermarket data set will be there. Based on that, it will try to predict what the customer will buy next based on your previous purchase list. Okay, daily you are going to a supermarket or weekly basis or monthly basis, you are going to a supermarket. Okay, every time you will be purchasing some products, right, in your name. Okay, they are collecting your information like that, you assume. Okay, what you will daily purchase is milk, bread, egg, butter. Those things you will be frequently purchasing means next time when the customer enters into that particular supermarket means it will give some suggestion. Similar like in e-commerce websites and all, it is giving suggestion, right, based on your previous purchase. That type of product alone it will be showing to you. Okay, constantly if you are buying mobile means it will what it will recommend, it will recommend back case, temper glass, so many things it will be recommending, right? If you are searching for laptop means it will be recommending you some accessories, like keyboard, mouse. Those kind of things will come under the association part. Okay, so when you go for the clustering means, so if I take the clustering, so again we are having separate algorithm for unsupervised learning. So here mostly we will be like seeing the k-means algorithm, we will be seeing then histographical clustering is there, principal compound analysis, single value decomposition, independent compounds analysis. Lot are there. In that K means will is one of the famous algorithm, and then hierarchical clustering is another one algorithm is there. Okay, then the third primary machine learning algorithm is we call it as reinforcement learning. So here in the diagram itself, if you see means each time the algorithm will be taking one decision, okay, based on our environment. Okay, if it has taken the correct decision means it will be rewarded. In case if it is taking wrong decision means it will be punished. Okay, so reinforcement learning is applied when the task at hand is to make a sequence of decision towards a final reward. Okay, so using this reinforcement learning only, the chess game, go game and all is there, right? The Chinese or Japanese game will be there. So what it will do is it will try to learn the opponent. What are all the moves the opponent is making? So based on that, it will change the decision, because chess game means opponent can make any move, right? So based on the move it has to change the pattern. So those cases it will be learning new things. If it is taking the wrong move, okay, it has made one move and the opponent has what we can say, uh, in chess game what we will say, the opponent is cutting your coins, some pond or anything is there means they, by making a move they can remove that coin, right? So it will assume that okay, if I make this particular move means opponent can able to cut my coin. So next time it will be very cautious how to make the next move. Okay, so same mistake it will not try to do the second time, then third time it will be like learning, like how human will learn from the pattern. Similar way our algorithm will also be learning and evolving. Okay, so here if you see in this particular example means one maze is there and inside that one rat you are putting for the first time. Okay, the maze is new to that particular rat. So what it will do is it will try to learn by moving. Okay, and in some places they will be keeping some cheese, and some places they will be keeping some trap. Okay, so each place it will try to go, wherever cheese is there it will remember, okay, next time this place cheese will be there, and wherever trap is there that also it will try to create it as a pattern. So next time it will not get into the trap. So wherever cheese is there, that part alone it will go. Okay, instead of getting into the trap. So those type of learning we call it as reinforcement learning. Okay, and we are having a lot more other hybrid learning methods also is there, like what we can say self-supervised learning. Okay, it is a form of unsupervised learning where the training data is automatically be labeled. Here in the unsupervised learning what I told, we will not label the data, right? But it all it will do is it will create some clusters and group it, right? But we need to give some label, right? Then only when new data I am passing it should say okay, this is uh, apple or this is banana or any name it should give, then we can change it, right? So for that we are having one another hybrid algorithm called self supervised learning. In that it will automatically give some label. Doesn't know it is an apple, but it will give some label. Okay, cluster 1, cluster 2, category 1, category 2, like that it will automatically label. So that we call it as self supervised learning. Okay, and then we are having semi supervised learning. Okay, semi supervised learning means we cannot directly I mean ask an algorithm to predict a value, right? We should have to be trained with some data, then only it can able to learn and evolve. So that we call it as semi supervised learning. In reinforcement learning also that will be happening. What we will do, we will train basic instruction we have to give to our algorithm, right? How to play the chess game, how to play the go game, that instruction we have to pass, then only it knows. King means how much move it has to make. Queen means how it has to move. Then what we are bishop, knight, and all is there, right? How it has to move, we have to train, right? That will come under the semi-supervised learning. It will be like between supervised and unsupervised learning. And then we are having self-taught learning. So self-taught learning means solving a supervised learning task given with both labeled and unlabeled data. Okay, For example, we cannot give the all the values as labeled. One 10 data, 100 data means a human can able to label it. What if 1 lakh data is there? We will not have that much human power to label all the data, right? It will take lot of time. So in that case, what we will do is, okay, partially labeled data we will pass into our program. Then based on that, it has to learn from the remaining. Okay, out of 1000 or 1 lakh data is there I'm having. In deep learning and all, if you are going means 1 lakh and all very small amount. Okay, lot of data we will be dealing with. So when the data is increasing means, obviously the training time, testing time also will be increased. So for that we will be going for you know some GPU and all we will be needing. Instead of CPU, we go for the graphical processing unit and all we need to process those type of data. So that also we will be seeing. We will not be going for that much higher level, but still we are having some data set with like thousands of datas or so many column values will be there, and how we are training our model also we will be seeing in that. Okay, then we are having multitasking learning also is there. Mostly machine learning will be like narrow means it can perform only one task at a time. As I told, if I created a machine that can solve or play a game of chess, means it can only play the chess game alone. It cannot go and play some other game. Okay, Rubik's cube solver also we have seen, right? It can only solve the Rubik's cube. It cannot go and play the chess game. So like that, it will be narrow based learning. Okay, but nowadays they are trying to make it as multitasking machine, so that it will not be focused on only one thing, but it can do multiple tasks. Okay, and what else is there? Transfer learning. Okay, another important learning is called as transferred learning. So here in the transfer learning, transferring of knowledge, like how human is transferring his knowledge to another human. Similar way, they are trying to convert a learning of one machine to another learning purpose. Okay, the main idea is to about transferring the knowledge of one supervised learning task to another. Hence, it will generally require some further labeling for a different as well as related task. For example, I have created one machine learning algorithm to predict cancer in blood. Okay, blood cancer I am predicting. Same cancer I want to predict in some other organ. Okay, for a liver cancer or anything means, again I don't need to start from this scratch. Cancer, how it will be, that is having some pattern, right? That pattern alone I will pass to a new model. But what this time, instead of checking for the blood, it has to check for different organ. Okay, so that is the another scenario. Okay, that we call it as transfer learning. Similar way, we are having so many learnings is there: active learning, you know, meta learning, enhanced learning. So many is there. Targeted learning. Targeted learning means only one particular specific target alone it will try to solve. Okay, then so up to this, any doubts is there? Like three different types of machine learning we have seen, and what are they we have seen? Okay. Then next question will arise is, why do we need an machine learning concept? So why do we actually need? Can anyone say why we are going for a machine learning concept? Okay, decision making when the input is huge. Okay, one thing. Then retrieve useful information from the data. Okay, to find accurate prediction. Okay, so we are saying accurate at the same time prediction only. So prediction will not be always 100% accurate also, right? There is a possibility of, even when we use in any field, we will say always 99 percentage, 99.99% it is just predicting, assuming. Okay, we cannot say whatever machine says it is the correct. We cannot say, right? Automation of everything. That also we can say. There is slight difference between automation and then the machine learning also. For example, if I say I'm having AC in my house, okay, based on the temperature, it will automatically turn on. If I'm setting some temperature, 27 degrees Celsius, I'm setting. Okay, so whenever it is less than 27, it will be turned on, or less or more means it will try to maintain the temperature. So this you will call it as machine learning or automation. This is just a automation. I have set some condition. Whenever the temperature reduces, based on the sensor, it will sense, each time it will be sensing whether it is 27 degrees Celsius or not. If it is low or high means turn on. That is my condition. But when it will be converted to a machine learning is, in my house four members are there. Okay, each time when I am in that particular room means I will set the temperature to 20 degrees Celsius. Okay, and my sister is there. She don't like AC means she is setting the temperature to 27 or 30 degrees Celsius. Okay, it will be recording us. Okay, when Vignesh enter into the room means he is setting the temperature to 20 degrees Celsius. When his sister is entering means it is a pattern, right? Each time that person enters means 30 degrees Celsius is keeping the temperature. When both of them are there, okay, you can ask how it will know Vignesh is there. Or my sister is, it means assume that one phase direction is there. Okay, based on the phase direction it is directing me and my sister, and my father or mother is coming means that time they are keeping different temperature. So like this it is happening for 1 or 2 months. So it is getting some pattern. What will happen when me and sister is there, like that it will try to take some decision. Okay, when Vignesh is, so next time after 1 month of training, next time when I enter into the room means I don't need to touch the remote, AC remote, automatically it will know. Okay, Vignesh entered, so we need to keep the temperature to 20 degrees Celsius. When my sister enters, it should be 27 or 28. Then next scenario is coming. What if two-person enter at the same time? I have entered and my sister are also in the same room. So it should automatically take some decision, right? Okay, it should not be 20 and it should not be 28. In between barely we can keep. Okay, so that both will not be changing the temperature. Like that some decisions are taken, right? That is what it will be converted from automation to machine learning. Okay. Yes, we can say like to carry out the manual activities. Okay, heavy task we can say, to reduce the manpower. What did you told? Mund, I don't get you. Okay, so humans are also evolving, and then the main thing what makes the difference between human and a machine is thinking ability, right? Even though we say automatically taking decision or anything means complete decision making power is in the hands of human only. Okay, uh, the machines are taking based on the data driven decision only it is taking. Okay, not based on the common sense or anything. So what we can say is to make decision based on data with efficiency and scale. Scale means we can do it for a large scale, because human cannot process a numerical value, right? If I'm giving a Excel sheet and I'm asking to find out the pattern means user cannot able to find out the pattern very easily. But for a machine it is very simple task, right? So that is where the need for machine learning take place. Okay. Then next question will rise is when we need the machine learning, when or why we need to make machine to learn. So there are several circumstances there, right, where we need our machine to take data driven decision with some efficiency and huge scale. So where at all we can say like lack of human expertise, we don't, if we don't have any human expertise in that particular field means, in that case we need some machine learning to take over the particular task. Then dynamic scenarios. If there are so many scenarios which will be in dynamic in nature, rapidly it will be changing time to time. So human cannot be able to adapt in that situation, right? So in those places we will be needing for we will be having a need for our machine learning to take the decision. Okay. Then difficulty in translating the expertise. For example, different language is there. Okay, one person is expertise in one particular language, and if he is trying to communicate in that particular language, as another human, he may not able to understand that particular language. For example, I know only Tamil and English. Okay, and a new person is coming and speaking to me in Hindi means I may not able to understand it. But for a machine, that won't be a big restriction, right? Because machine to machine it is going to communicate in same language, and it will not be hard for a machine to learn a new language, right? Because end of the day everything is going to be converted from zeros to ones only, it is going to convert. So it won't be a problem for a machine to learn a new language, adapt to the environment. For example, we can put a same machine in an Antarctica or near to a volcano also, it is not going to affect. Okay, but for a human it is difficult to adapt to different climate, different food temperature, everything is there, right? So those places we will be needing for our machine learning, right? Any doubts is there till here? Okay. Then next thing is how or what are all the things we need to learn this machine learning. So first thing is programming language. So what are all the programming language we have learned in the data science part? We have seen R and Python, right? So for machine learning also, we can use either R programming language or Python programming language. Here we will be using the Python programming language because it is having lot of libraries and frameworks. Okay, main thing is for the deep learning and all, we are having so many frameworks are there. So we will be writing our program in Python. Okay, that is the first thing we need. So that is the reason we are learning Python basics in the beginning. Okay. For all the base we have learned for the Python, in the Python is for the machine learning only. Okay. Then next thing is we need to have some skill sets. So what are all the skill set we need is, so first is we need to have some basic mathematical skills. Okay, basic mathematical means what are all the things are linear algebra, calculus, probability, at least some basic knowledge. So you can recall the basics of all these things. We will not be directly using those formulas. Okay, for example, probability and all we will be indirectly using in the algorithm. Okay, uh, we are having like bias theorem will be there, so many things will be there. So those and all will be using the probability logic only. So if you don't know the basics of probability means you may not understand the formula. So if you don't understand the formula means you cannot able to understand the algorithm, how the algorithm is working. So if you don't know how the algorithm is working, you may not be able to train the model. Okay, if you know what is the algorithm, what algorithm it is using, so what is the formula for that particular algorithm, then only we will know which data will be suitable for which type of algorithm. So those and all we can able to analyze then only. So basic mathematical skill we need like linear algebra, calculus, and then probability we need to know. Then In the statistical part, what are all the things we need to know is, so mean, median, variance, standard deviation, those things we have seen, right? So again, in the statistical part also, we are having probability, inferential statistics, a little bit deeper. Okay, correlation between various components we need to know. Okay, hypothesis testing. Hypothesis testing means we will be creating one scenario and we will check whether it is true or not. Like null hypothesis is there, so many two, three hypothesis is there. So based on that, we will be testing the scenario. Okay, for example, I have told right whether the rain will come or not. One scenario is there means you will be first checking with yes, rain will come. In that basis, you will try to prove that statement. If we are unable to prove that statement means obviously rain will not come, right? Like that we will be switching. So that we called as hypothesis testing. Okay, normal distribution range. Okay, mode and standard deviation and all we need to do in the statistical part for performing the data analytics. Okay, then database. Okay, here we are not going to deal with the actual database. Okay, every data will be going to be in the CSV format and in our local file. But if you are creating an application means, or when web application or desktop application means, obviously we will be needing some database to store all the data, and we will need some connectivity, okay, between the programming and as well as the database. So here we are having various databases like MySQL, MongoDB, like web based if you are going means MongoDB, so many places they are using, and MySQL, PHP MySQL is there, which is like commonly used in so many applications. Web application we will be using basic MySQL, and in your syllabus you are having Cassandra also, right? So for big data analysis, we need this Cassandra. Okay. So that is database part. So you should know how to connect with between various databases. Okay. Then, so these are the important steps that we will be following in upcoming classes. So you just note it down these steps. Okay. This will be like an order. So first and foremost thing we need is gathering the data. Okay. So first, before gathering data, we need to know what is your problem statement. For what problem you are trying to solve or trying to find a solution. So based on your problem, you have to collect the data, right? So that will be the first step. I have to collect the data. Then in the second step, what we have to do? We have to do some data pre preparation. So in the preparation part, we will be using some pre-processing, like removing the missing data or converting the missing data into some useful data or converting the categorical data into numerical data. So all type of pre-processing you will perform in this data preparation part. Okay, gathering data means raw data directly getting from the user. After that, we have to clean the data, process the data. Then that will be the second part. Then choosing a model. Okay, this is part alone will going to be change in each algorithm. Okay, for this particular data, what algorithm I have to use. So that is nothing but the choosing of a model. So once you have choose your model, then you have to train your model. Okay, we are having data in some form, right? So that data will be separated into four parts. Okay, that I will just try to draw. Okay, so assume that you are having data. So okay, multiple columns are there. So I'm just giving column 1, column 2, column 3, column 4. Okay, assume that it is a supervised learning. So we are having some labeled data set. Then mostly last column or whichever column along with the data we will be having some output column also. Okay, so output column we will be splitting it separately. Okay, so this we assume that we are having 100 data. Okay, out of this 100, 80 percentage of the data we will take for training. So this is just a approximate percentage only. It doesn't mean always you have to take 80 percentage only. We can take 90 percentage also or 85, varies. Okay, based on the if you are having very less data means we have to take accordingly. More data means we can take 90, 95 percentage of data also we can take for training your model. Okay, this we call it as X train. Okay, and this remaining 20 percentage we will call it as X test. Okay, for testing purpose we will take the remaining 20 percentage. Okay, and for the output column, the entire column is there, right? Four column is there, assume. In that first three column, useful columns alone, we will take it as X. X is nothing but independent variable, or we can say it as features of our uh, model. So independent variable, and the output column we call it as Y, and it is nothing but the dependent variable. Okay, sorry. So Y we will call it as a dependent variable. Okay. So here also X train X test is there, right? So here also same 80 percentage we will take for Y train, and then remaining 20 percentage for Y test. Okay. So what we will do is first we will pass this entire values here, right? This we will pass it for training purpose. Then after training has been completed, we have seen, right, training. We will pass this testing. Okay, and our model will return something, right? So that we will store it as Y predict. So Y predict means predicted value. So this will be the user machine predicted value. So later on, we will compare this machine predicted value with the actual value which is present in the Y test. Okay, for example, what we can say is house price and all we are saying continuously, right? So for assumption, it is actual price. Okay, number of rooms is there. Okay, number of entire, I mean, number of all rooms, number of bedrooms, square feet, so many columns are there. So based on that, it has been predicted that 10,000 rupees, okay, rent I'm talking about 10,000 rupees rent we can give for that particular house base square feet, like I don't know the exact square feet, so I'm just giving 800 square feet is there, five rooms is there, in the two bedroom is there. So for that 10,000 rupees rent is there. Like that, it is the actual value, right? But I will only ask to the machine 800 square feet is there, five rooms are there, in that two bedrooms are there. What can be the price of rent of that particular house? I will ask. So it will say, okay, 9,800. It can be the price based on his previous analysis. Okay, but actual value is 10,000. So what is the difference? So likewise, we will check for all the values and we will come to an conclusion. Okay, this model is predicting this much percentage correctly. Okay, it is almost close, right? Only 200 rupees less. So we can say like, okay, 95, 96 percentage, it is predicting closer to the actual value. Okay, like this, we will be splitting our data. Okay, okay. Then So that is what we call it as evaluation. Training we have given, then we have to evaluate it, right? So in this way only we will evaluate it, how much it is predicting or not. Then parameter tuning. In case we are not getting the expected percentage, then we will make some tuning parameter will be there. Like if you are changing few things means it will increase or decrease the percentage. So it is good if it is increasing. So at some point of time it will not be increased. Okay, after 95 percentage, even if you are changing the parameter also, it will be like either it is decreasing or it is the value is not more than 95 percentage means we will stop in that particular point. Then we will finally predict it. Okay, final prediction means I will be passing some new value. In some cases I will pass some new value, okay, which is not even present in my data set also. Completely new value I will pass and I will check whether it is predicting correctly or not. Okay, so that is the final step. So these 7 steps only we will be using repeatedly. So okay, gathering data, data pre-processing. In this data pre-processing, what we can say. So data cleaning will be there. Then handling the missing data will be there. Then what we can say. Uh, uh, Converting categorical data into numerical data. For that, what name I have told? Encoding, right? Two types of encoding I have told. One is like converting numerical, sorry, categorical to numerical. Then frequency encoding. Remember, so encoding is there. In this encoding also again two category will be there. Normalization, standardization will be there. That we will see in the later classes. Okay. Yes. In the point three, choosing a model means choosing our algorithm. Okay, what algorithm I'm going to use for that particular data. Various algorithms we have seen, right? So we know whether it is supervised or unsupervised. So based on that, each day you will be seeing different algorithm. Okay, for different data set, different problem, we can say different project. Each day we will be seeing one algorithm. Okay, up to here, clear for all. Any doubts? Okay. So given a large data, how to identify which algorithm? No, no, this is totally up to us. Okay, we can use and check all the algorithms also in the same data set also. Okay, to make it easier, I will be using one algorithm for one data set, and in the lab session, I will ask you to use different algorithms. We will be using different algorithms only. Why? Because same data set for one algorithm, the percentage of accuracy will be 86. In another algorithm, the percentage of accuracy will be 93. So like that, it will be varying. So you have to use different algorithms. And what type of output you want? We have seen two type of classification, right? I mean, two types, right? Whether it is a classification type or regression type. So based on that, we will be using those algorithms. If it is a classification, means we will check with the decision tree classification is there. SVM, we can use SVM for classification. K nearest algorithm. So like that, we will be using all the algorithms and we will check which is giving the highest accuracy. Then that algorithm only we will be using for a prediction purpose. Okay. And what type of output also we need. regression model means linear. Okay, first we will check with some cases, we will check with linear, okay, whether it is creating pattern or not. And another method what we will use is to identify is we by using the graphs. Okay, um, for example, so is my PPT visible? PPT. Ah, PPT visible, right? Okay. So that is why we will go for data visualization. See, assume that I'm having some X and Y. So I have told X means what? Independent or dependent? D means dependent, I means independent. Okay, like that you assume. And I'm plotting all the values in the graph. Okay. So like this, I'm plotting. So if you see means what pattern you can able to see from here. When the X value increases, the Y value also getting increased, right? So obviously, linear line if I draw means I can able to connect most of the dots. So I can say I can use this linear method. Okay, same thing. Okay, instead of going like this, if it is like this, so it is not like a straight line, right? Some bend or curve is there, right? So for that, if I draw a line like this means, can I connect most of the points? So this is nothing but polynomial regression. Okay, first in polynomial regression also, first we will draw the straight line, then slowly we will try to change the parameter. In linear regression we cannot change, it will be like straight line, but the position alone will be changed. Okay, so what problem we will be facing is we cannot able to see for this second type. Okay, type 2 is there, type 1 is there. So if I use type linear regression in this model means what will happen? It will simply draw a straight line like this. Correct? If it is do means what will happen? It cannot able to cover most of the point it can cover. So our model will be giving very less accuracy. Okay. Whereas if I use polynomial means it can give more accuracy because it is covering most of the points, right? Similarly, for different problems, okay. If I go, wait, shall I erase this? Erase, I will go to news. So again, I'm drawing. So if my, plottings are like this, then what algorithm I can use? So I can use classification related algorithm, right? So I can easily classify them into three parts, right? So whichever coming under this particular point, I can say like product one, whichever coming under this point, I can say product two, product three, right? Product or some example we can say. Okay. So like this, we will be understanding the pattern. If I go for the supervised learning means, uh, whether it is a labeled data means we will be using this method. If the same thing, okay, it is comes under the unsupervised learning. I don't have any labeling. For example, product means okay. This is pen. Okay, these are all pencil marker. So it is labeled data, so I can easily differentiate. What if it is an unlabeled data? Hmm. I will use clustering method. So for creating clustering, what I will do is I will create some circles. Okay. So cluster 1, cluster 2, cluster 3. Like that I will separate the data. See, it doesn't means evenly everything will be splitted. We cannot say. Some points will be missed also. Here and there some points will be there. Some point will be touching the like border of one type. So everything will happen. So these type of missing data we can call it as outliers. Okay. Whichever is not coming under the pattern. Likewise, depend upon the problem, depend upon the output expected pattern, algorithm will be changing. Okay. Okay. So so if any no doubts means I will wind up the session. Okay. Thank you all.